Hello everyone, welcome to EAT TikTok. My name is Narala Siddhartha. My roll number is 20951A6744. My branch is Computer Science Engineering with Data Science as specialization. My subject is Data Management and Representation. Today my topic is a study of handling missing data methods for big data. So let's start the session. So I mainly divided the content into three parts. In the first part, we are going to discuss about the big data. In the second part, we are going to discuss about the missing data. In the third part, we are going to deal and handling missing data methods for big data. First one, big data, the basic idea about the big data and its uses. So, big data. What is big data? Big data is a combination of structured, semi-structured and unstructured data collected by organizations that can be mined for information and used in machine learning projects, predictive modeling and other advanced analytics applications. Systems that process and store big data have become a common component of data management architectures in organizations, combined with tools that support big data analytic uses. Big data is often characterized by the three V's: the large volume of the data in many environments, the wide variety of data types frequently stored in big data systems, and the velocity at which much of the data is generated, collected, processed. These characteristics were first identified in 2001 by Doug Laney, then an analyst at consulting firm Meta Group Inc. Gartner further popularized them after it acquired Meta Group in 2005. More recently, several other V's have been added to different descriptions of big data, including veracity, value, and variability. Although big data doesn't equate to any specific volume of data, big data deployments often involve terabytes, petabytes, and even exabytes of data created and collected over time. Why is big data important? Companies use big data in their systems to improve operations, provide better customer service, create personalized marketing campaigns, and take other actions that ultimately create increased revenue and profits. Businesses that use it effectively hold a potential competitive advantage over those that don't, because they are able to make faster and more informed business decisions. For example, big data provides valuable insights into customers that companies can use to refine their marketing, advertising, and promotions in order to increase customer engagement and conversion rates. Both historical and real-time data can be analyzed to access the evolving preferences of consumers or corporate buyers, enabling businesses to become more responsive to customer wants and needs. Big data is also used by medical researchers to identify disease signs and risk factors, and by doctors to help diagnose illness and medical conditions in patients. In addition, a combination of data from electronic health records, social media sites, the website, and other sources gives healthcare organizations and government agencies up to date informing on infectious disease threats or outbreaks. Here are some more examples of how big data is used by organizations. In the energy industry, big data helps oil and gas companies identify potential drills, locations, and monitor pipeline operations. Likewise, utilities use it to track electrical grids. Financial services firms use big data system for risk management and real-time analysis of market data. Manufacturers and transportation companies rely on big data to manage their supply chains and optimize delivery routes. Other government uses include emergency response, crime prevention, and smart city initiatives. The history of big data. Although the concept of big data itself is relatively new, the origins of large data sets go back to the 1960s and 70s when the world of data was just getting started with the first data centers and the development of the relational database. Around 2005, people began to realize just how much data users generated through Facebook, YouTube, and other online services. Hadoop, Hadoop, an open source framework created especially to store and analyze big data sets, was developed that same year. NoSQL also began to gain popularity during this time. The development of open source frameworks such as Hadoop was essential for the growth of big data because they make big data easier to work with and cheaper to store. In the years since then, the volume of the big data has skyrocketed. Users are still generating huge amounts of data, but it's not just humans who are doing it. When the advent of the Internet of Things (IoT), more objects and devices are connected to the Internet, gathering data on consumer usage patterns and product performance. The emergence of machine learning has produced still more data. While big data has come far, its usefulness is only just beginning. Cloud computing has expanded big data possibilities even further. The cloud offers truly elastic scalability where developers can simply spin up ad hoc clusters to test a subset of data, and graph databases are becoming increasingly important as well as with their ability to display massive amounts of data in a way that makes analytics fast and comprehensive. Big data benefits. Big data makes it possible for you to gain more complete answers because you have more information. More complete answers mean confident in the data, which means a completely different approach to talking problems. More characteristics of big data. Veracity refers to the degree of accuracy in datasets and how trustworthy they are. Variability also often applies to sets of big data, which may have multiple meanings or to be formatted differently in separate data sources. So, second one, missing data. Missing data or missing values occur when you don't have data stored for certain variables or participants. Data can go missing due to incomplete data entry, equipment malfunctions, lost files, and many other reasons. Types of missing data. Missing data are errors because your data don't represent the true values of the what you see out to measure. There are three main types of missing data. They are missing completely at random (MCAR). Missing data are randomly distributed across the variable unrelated to other variables. Missing at random (MAR). Missing data are not randomly distributed but they are accounted for by other observed variables. Missing not at random (MNAR). Missing data systematically differ from the observed values. Missing completely at random. When data are missing completely at random, the probability of any particular value being missing from your dataset is unrelated to anything else. Missing at random. Data missing at random are not actually missing at random. This term is a bit of a misnomer. This type of missing data systematically differs from the data you have collected, but it can be fully accounted for by other observed variables. Are missing data problematic? Missing data are problematic because depending on the type they can sometimes bias your results. This means your results may not be generalizable outside of your study because your data come from an unrepresentative sample. How to prevent missing data? Here are some of the tips you have to use in order to minimize the missing data. Limit the number of follow-ups, minimize the amount of data collected, make data collections forms user friendly, use data validation techniques, offer incentives. So third one, handling missing data methods for big data. Best techniques to handle missing data for big data are: use deletion methods to eliminate missing data, use regression analysis to systematically eliminate the data, and data scientists can use data manipulation techniques in order to handle the missing data that are found in a big data. Keeping things under control, that is minimizing the and preventing the missing data, may be better than solving again after the missing data values have been found in a dataset. Thank you.